A very good morning, class 12th. The agenda for today's class is Unit 11, Alcohols, Phenols and Ethers. And I'm talking about the videos that are already posted on the channel. There's a playlist with this particular name. It has got 13 videos as of now, and I'll be making today's video. This video has 5 videos related, this playlist has 5 videos related to phenol, majorly covering it up. Ethers, there's just one video. Alcohols, there are 7, and I'm making the next video of alcohols right now. The topic of today's video is classification of alcohols. Now, when you classify the alcohols, the first basis of classification is based on the number of OH groups in a particular compound. Monohydric is the word used when there is just a single OH attached in a compound, which could be this, it could be this. It has to be just a single OH. Dihydric alcohol means there are 2 OH groups attached to your compound, which means you have a OH here, let's say, and a OH here. Hydrogen, you need to balance it out for the valency of carbon. So you have this kind of a compound is called as dihydric. Polyhydric or trihydric means there are 3 OH groups or there are beyond 3 OH groups. For example, I have a compound like this, 3 carbons. All the 3 carbons have 1 OH group each. Satisfy the valency. This particular compound is a special compound also called as glycerol, or it is called as 1, 2, 3 trihydroxypropane, or it is a propane 1, 2, 3 triol. That's also the name. Now under this category, if I have a compound like this, which has got 2 OH groups, but both the OH groups are on the same carbon, such a compound is unstable. It actually loses a water molecule like this and leads to an aldehyde. So whenever there are 2 OH groups on the same carbon, we say that it is unstable and it will quickly transform into an aldehydic group. So there is nothing called as a geminal diol because it is unstable. 2 OH groups on the same carbon remain unstable. The same classification is also applicable to a benzene ring. Let's say I have a compound of benzene which has got 3 OH groups like this. This particular compound is also a symmetric compound, which can be benzene. You have 3 OH groups. So benzene, symmetrical benzene triol means it has got 3 OH groups symmetrically placed on benzene. So this comes under the category of trihydric alcohols. Moving to the next category of classification. Now this particular category depends on the carbon to which the OH is bonded. The carbon can be sp3, it can also be sp2. These are the 2 main ways of classifying the alcohols. What is an sp3 carbon? An sp3 carbon has 4 sigma bonds, while an sp2 carbon has got 3 sigma and there has to be 1 pi bond. So when I talk about this category of a carbon, it would have 4 sigma bonds, out of which 1 would have your OH. So this particular compound falls under the category of this one, where OH is bonded to a carbon which has got 3 sigma bonds, that is, it is under this category. While if I talk about this particular one, you have an OH group attached to a carbon which in turn is involved in a double bond. So since this particular carbon in this case has got 3 sigma bonds and 1 pi, this falls under the category of sp2 hybridized carbon, while this is your sp3 hybridized carbon. So this is the category when I'm talking about an OH attached to a carbon which has got sp3 hybridization, and this is the category when I talk about OH attached to a carbon which is sp2, means it has to have a pi bond. Also, if you check on this, what is this? This is cyclohexanol, and if I write it like this, this becomes phenol. Now let's check the carbon to which the OH is attached. This particular carbon, as you can see, has got 3 sigma bonds and 1 pi bond. Therefore, this also falls under this particular category where OH is attached to a carbon which has got a sp2 hybridized carbon. Let us do the details of each of the categories. So the first category that I was talking about was that your OH group is attached to a carbon which has got 4 single bonds or 4 sigma bonds. So it is sp3 hybridized. Under this category you have 5 types: primary alcohol, secondary alcohol, tertiary alcohol, allylic alcohol and benzylic alcohol. Let's do them one by one. Moving on to the first category, a primary alcohol is also referred to as 1 degree alcohol. Now this is the one which would have an OH group attached to a carbon which in turn is attached to a single R group. It should have 2 hydrogens attached to it. So then it is called as a primary alcohol. Or else OH is attached to a carbon which is attached to no R group. It has got 3 hydrogens. That is also a primary alcohol. This you can easily see. OH is attached to a carbon which has got 2 hydrogens and there is 1 R group. So all these fall under the category of primary alcohols. Moving on to the second category, which is secondary or the 2 degree alcohol. Now in this particular category, your OH group is attached to a sp3 hybridized carbon which should have 2 R groups and it should have just a single hydrogen. I'll take a specific example: CH3, CH, CH3 and an OH here. Have a look at this. Now OH, you can see carbon के पास कितने bond है? 1, 2, 3 और 1 ये 4. Out of 4 bonds, there is 1 OH and 2 are R groups and 1 is H. So the OH is attached to a carbon which should only have a single hydrogen. Comes under the category of secondary alcohol. This particular compound is a propane with an OH at the second position. This is commonly called as isopropyl alcohol. And IUPAC nomenclature, it would be propan 2-ol. But this you should know. What do you mean by isopropyl alcohol? Moving on to the next, tertiary or a 3 degree alcohol. Under this category, we have the OH group attached to a carbon which should be sp3, means it should have 4 sigma bonds and all the 3 should have R groups. Now they can be same, they can be different also. I'll take specific examples now. I have a compound like this. This would fall under the category of 3 degree alcohol. This is also called as tert butyl alcohol. Means it's a tertiary butyl, 4 carbons in all, and it should be a tertiary butyl. That is, your OH group is attached to an sp3 hybridized carbon which has no hydrogen. All the 3 groups are R groups. I'll take another example for your sake. An OH group is attached to a carbon which is attached to carbons like this. This also falls under the category of 3 degree alcohol because OH is attached to a carbon which has got 4 sigma bonds. Also, all the 3 bonds attached other than OH are R groups. They are different. Here they were same. The fourth category is called as an allylic alcohol. अब ये क्या होता है? An allylic alcohol में OH group is attached to a carbon which is sp3. मतलब उसके पास 4 बॉन्ड तो होने हैं, लेकिन after which there has to be a double bond unit attached to this particular carbon. So when you have an OH attached to a carbon, as you can see, this is sp3 and this sp3 carbon is attached to a double bond unit, we call it to be an allylic alcohol. Let me give you a few more examples on this category. Have a look at this. Can you see this? OH is attached to a carbon. इसमें बेटा 3 ही bond दिख रहे हैं, but it has a 4th hydrogen to it. OH is attached to a carbon which in turn is attached to a double bond unit. So this falls also under the category of allylic alcohol. Another example. This is also an allylic alcohol. Have a look at this one now. Pay attention. OH is attached to a carbon which has got 4 sigma bond, it is sp3. This is attached to a double bond unit. So it has to be allylic. But this sp3 carbon also has another R group, which means you can see that in this case your OH is attached to a carbon which is attached to 2 carbons here. So this can also fall under the category of secondary and allylic. Fine. It is 2 degree because the OH to which the carbon is attached has got 2 R groups, and also it is allylic because the carbon to which OH is attached also is attached to a double bond unit. Now before I move ahead, let me give you an important piece of information about allylic alcohol. An allylic alcohol easily undergoes substitution reactions. The nucleophilic substitution reactions are easily done on an allylic alcohol. Why so? This OH takes away the electron and leaves. If that happens, you end up in a carbocation like this. Now this carbocation is stabilized by resonance. That is, this carbon requires electrons, the pi electron shifts here, you get a CH2, CH, a double bond here. This carbon has not affected because now it had double bond here and one single bond here. Now the bonds are shifted, but there is no loss of electron. This particular carbon gets satisfied because the electron shift here, while this particular carbon has lost electrons, so this becomes positive. Now since this is resonance stabilized, means an allylic alcohol can easily lose a OH group to cause a substitution reaction. So this is highly reactive. 2. Nucleophilic substitution reactions. Moving on to the last category, which is the benzylic alcohol. Now under this category, you have an OH group attached to a carbon which has to be sp3 and it is attached to a benzene ring. Pay a close attention to this particular carbon. This carbon, as you can see, has got 1, 2, 3 and 4. So it has got 4 bonds. So this carbon is sp3, but there has to be a benzene ring attached to it. So under this category, this compound is called as a benzyl alcohol. Please remember this. This is benzyl alcohol. Benzene attached to a carbon which is attached to a word. Benz is the word used when you have a benzene with a carbon on it. Remember that for life. Under this category, let me give you another example. Have a look at this particular compound. Now this particular compound has an OH group attached to a carbon which is sp3 and it attached to a benzene ring. So it definitely is a benzylic group. But you have, this particular carbon has 2 R groups. So it is 2 degree benzylic because it is secondary also. Fine. Moving ahead. So we finished the detailing of the categories under this particular fall where you have an sp3 carbon and your OH is attached to a sp3 carbon. We did each one of these categories: primary, secondary, tertiary, allylic and benzylic. Now we are left with the second category. The second category has an OH group attached to a carbon which has a pi bond, so it is sp2. Under this category we have only 2 options. One is vinylic, the other is aryl. Now when I talk about a vinylic group or a vinylic alcohol, this one has an OH group attached to a carbon which itself is involved in a double bond. So you have a CH2, you have a CH2. This is, produce CH. This falls under the category of vinylic alcohol, and OH is attached to a carbon which is involved in a double bond itself. So if you have a compound like this, this would again be vinylic because OH is attached to a carbon which is sp2 because it has a pi bond here and it has a R group. That is not important, But since the OH is attached to a carbon which is sp2, so this would be vinylic. Please do not call it secondary. The reason is sp2 carbons are never classified as primary, secondary and tertiary. Primary, secondary and tertiary are applicable only to an sp3 hybridized carbon. So this is merely vinylic. Fine. The second category under this particular classification is an aryl alcohol or phenol where the OH group is directly bonded to the benzene ring. Such a compound is called as aryl alcohol. Have a close look at this particular carbon. This particular carbon, as you can see, has 3 sigma and 1 pi, so falls under the category of sp2 hybridization. So this category is when the OH is directly bonded to benzene, it is called as phenol. But if the OH is not bonded directly to benzene, it is bonded like this, then it is called as benzylic alcohol. Let's talk about the reactivity of vinylic and aryl alcohol first. Now this is your vinylic alcohol. Now in this case, you have a bonded here. This is an sp2 hybridized carbon, so this OH cannot easily leave. In fact, it has a resonating structure like this, where you can see that this particular bond has developed a partial double bond character. Therefore, it is a strong bond, hence difficult to break, so the OH does not leave easily. This therefore is not reactive to nucleophilic substitution reactions. The second category is that of aryl alcohol. As you very well know, please refer to the plus R effect video on my channel. OH has got lone pairs, so it acts as a donor and this bond leaves here. So your resonating structure begins with this kind of first resonating structure where you can clearly see that you have a partial double bond character again. Hence, the carbon to O bond becomes strong bond. It is difficult to break. The OH does not easily leave in case of phenol also. So again, this is also not reactive to SN reactions like that of vinyl alcohol. I missed out on the benzyl alcohol's reactivity. This is your benzylic alcohol, and these lone pairs are not involved in resonance because the pi bond is far off. So the resonating structure that it has would have not got this, and it causes this bond to be pulled by oxygen and this leaves easily, which leads to the formation of a benzylic carbocation. And this benzylic carbocation is highly stable due to resonance. Let me draw the resonating structures. This carbon requires electrons, so this pi bond shifts here, leading to a double bond here. The charge gets neutralized, but this particular carbon gets a positive charge. The resonating structures continue. This bond shifts here, this pi bond I'm talking about, leading to this goes here, you get a positive here, and your CH2 stays. Please draw a double-headed arrow between resonating structures. This bond again is requiring electrons, so pi bond shifts here, leading to nothing happens here. This bond goes here, this bond goes here, this is a positive. As you can see, it is resonance stabilized. अगर ये resonance stabilized है, means this reaction goes in the forward direction, OH easily leaves, that means this is reactive to nucleophilic substitution reactions, while phenol is not reactive to nucleophilic substitution reactions. So, till now we did the classification and the reactivity of the different types of alcohols of this chapter. Now to wind up the class, I will be doing some examples for you to get the grasp of the topic. We will quickly classify the following alcohols. This is the first. Can you see the OH is attached to a carbon which is having no pi bond, so it is sp3. Since it is sp3, this is called as either primary, secondary or tertiary. Since you can see it also has 2 R groups attached to it. Hence this becomes a 2-degree alcohol, secondary alcohol. Fine. Moving to this particular one, OH is attached to a carbon which is an sp3 carbon but is attached to a benzene unit. So this falls under the category of benzylic is the first thing. Also this carbon is sp3 and it has got 2 R groups. So it is a 2-degree benzylic alcohol. Talking about the next one, OH is attached to a carbon which has got no pi bond. It is sp3 and it has got 2 hydrogens, no R group. There's just 1 R group, 2 hydrogens and 1 R group. So it is a primary alcohol. Coming to this one, OH is attached to a carbon which you can see is sp3. This carbon has got 3 R groups, that's 1, so it has to be 3 degree. Apart from this, the carbon is attached to a double bond unit, so it is 3 degree allylic alcohol. Fine. Think about this one. I have deliberately given you a chloro because this classification is valid on chapter 10, haloalkanes. Actually, the classification in haloalkane compounds chapter unit 10 and the classification in unit 11 remains the same. You can see this is a halo compound attached to a carbon which is sp2 and it is involved in a double bond. So this is vinylic halide. Agar ye OH hota, it would have been vinylic alcohol. In fact, the classification of alcohols and halo compounds remains same. So if you understood any one of the two, the second part would be easier for you. With this, I come to an end of the class. Hope you are liking the video. It's been a long time that I've posted the video. Do share and like the videos and keep loving chemistry. Bye. This is Seema Makhijani signing off for today's class.